So hello everybody. I have to say good morning or good afternoon or even good night to some of you. I even see that we have customers from Asia here. So that means that is the middle of the night. As you know, usually we would invite you to this building, but this is not possible because of this COVID-19 pandemic. So we like to give you an update with this online seminar about the news of liquid analysis instrumentation in the food and beverage industry. And as you know, the liquid analysis instrument is not only to measure the parameters, it's also to help you ensuring your product quality and your safety in your process. Let me first introduce how the system is working. So I need a little bit my glass now. So first, you can decrease or increase the picture of the speakers, either to the top or to the side. And then, of course, you can download the presentation. So we have the presentation already on the server. You just can download the presentation, so you have all the material, including the links to all these topics. Then, I have to move this a little bit. So if you have any questions, so don't hesitate to write your questions right away in the chat box. We will either answer them directly during the presentation. Otherwise, we will have a question and answer session at the very end. So then we will discuss about the questions at the end of the presentations. And the session will be recorded. That's maybe also important. So if you like to share this presentation later on with your colleagues, or if you know somebody who had not the time to see this seminar, so you can, let's say, end of the week, you can download this session and can share it with your colleagues or for your own reference if needed. So who will be the speakers of today? That's me, Matthias Schützeberg. I'm the Industry Development Manager here in Rheinach, Switzerland of Endress Hauser. I'm the moderator of this session, and I like to welcome as well my colleagues, Maria Florencia and Dr. Michael Weiss. They are from the German side of the production and R&D department of the liquid analysis instrumentation, and they will give you the news about these instruments from now.
So welcome everybody from my side. I'm Maria Florencia Perez Lippi. I live in Germany, but I come from Argentina. I'm working in E&H since 10 years, the first 3 in Argentina. And since 7 years, I'm located here in Gerlingen, Germany, working as an area manager of Latin America, Spain, Portugal, and Ireland. And also for sales responsible for food and beverage industry. And I work together with Michael Weiss.
Perfect. So welcome from my side as well. That means good afternoon to Europe and good morning, Americas. Yeah, as mentioned, my name is Michael Weiss. I'm working with E&H more than 15 years in different positions, but always with a wonderful world of liquid analysis. And my actual position is now the industry manager for food and beverage at Liquid Analysis, and I'm really looking forward is now to discussing the different topics. And please, Flork, you can continue.
So I will start with the presentation, then Michael will take the lead. We will discuss during this online seminar well, a small introduction of our liquid analysis portfolio, then some parameters and which portfolio are supporting these parameters, some applications examples, then we will make a small brief on utilities, and in the end, a small conclusion. So I will start now introducing our house. So we have, just a small second. Yes, so we have different sites. On one side, we have sites in Germany. We have sites also in China and in US. In China, we serve the Asian market mainly with these products that we produce there. Then in Anaheim, in California, US, we produce super special process photometers that we deliver worldwide. And also we produce a big part of our instrumentation, and we stock also instrumentation there to serve the Americas. Then in Germany, we have 3 sites. Our headquarters in Gerlingen, that is where I live, not in the headquarters, but in the neighborhood. There we produce most of our instruments, and we have research and development, the same as in Anaheim, California, and also in Waldheim. Waldheim is other of our sites that is here in Germany, where we produce most of our sensors, and we have also research and development. And last but not least, Groß-Umstadt, that is close to Frankfurt here in Germany. There we produce our big project container and panels that we will see also later. Altogether, we are more than 1,000 employees. And together with our amount of employees is the amount of patents that we have, more than 1,000 also. And that's because for us it's really important to investigate, to make research, to make development of new instrumentation, and that you will see on the next slides. Which instruments do we serve? We have focus in 7 industries, like wastewater, food and bev, power and energy, mining, chemical, oil and gas, and life science. Life science is a little bit of biotechnology, pharma industry, healthcare. How is a loop for us? A loop of measuring is of measurement. It's a transmitter, as you see there, a cable, then a sensor, that is what you see inside this assembly, that the assembly is what is helping us to put the sensor and connect it to the measuring point. We sell more than 70,000 transmitters per year, 2,000 analyzers. Analyzers you will see after, but they are a little bit different to the sensors. They are bigger instruments, and they are making a reaction inside and a mixing between the sample and a reagent. Then we sell also more than 15,000 assemblies and more than 400,000 sensors per year. Why do we sell so many sensors? For example, in pH, we are market leaders selling pH sensors, and we have a big variety for all these industries that we are serving. Now coming to our portfolio. As you see, we have more than 30 parameters that we measure in the liquid analysis line. pH, ORP, pH ISFET, and even if you see inside each of the parameters, we have different options of sensors. The main reason is because we serve these 7 industries, so we have hygienic instrumentation, non-hygienic instrumentation, X-approved instrumentation, and that's why you will see the variety inside of each parameter. We offer ion selective, turbidity, disinfection portfolio, dissolved oxygen, and here below you see the analyzers. That is what I spoke in the last slide. The analyzer is different to these sensors that basically they have a parameter and they measure whenever you put them into the liquid. The analyzers are taking a sample, they are mixing with a reagent. This mixture gets inside normally a photometer, and after some minutes of reaction, they are giving you the concentration of each parameter that you would measure. This is done as it would have been done in the lab. For example, for COD, that is the chemical oxygen demand, when we are speaking about the wastewater treatment plant, other phosphates or total phosphate, and that is, for example, important in the soft drinks industry. Now going to the food and beverage industry, we have normally coming in raw materials, water, and energy. Then coming out, the final product, and also our waste, our effluent. And in between, we have our process control. We need to optimize this process, cleaning and sterilization, and also what we call inline quality monitoring. What is important is that with all the instrumentation we have seen in the last slide, we can support you in each of these steps. So coming in, for example, as an example, in the raw materials, perhaps you need to measure pH and conductivity when you're receiving milk. Then inside, you need to measure different parameters in order to make a good quality monitoring of your product. And then in the end, you need also to meet some requirements of your final product, where we have these hygienic sensors to support you. And also in the wastewater, we have all the portfolio needed to support this monitoring. Going to the hygienic portfolio, what we have is pH, conductivity, dissolved oxygen, process photometers. The process photometers that are the ones that I told you that are being produced in Anaheim. These process photometers are normally used for turbidity, for fermentation control, for color measurement. Yeah, what is important is that we connect all our sensors that you see in the same transmitter. That is the one that you see here above, sorry. And on top you have the assemblies, and something that we have to support also the automation of your process. On the right corner, you will see a device that is helping you to calibrate and measure the with the pH sensor. So you have in the process a pH measurement, you take it out, you clean the sensor, and you calibrate with this device that then Michael will explain you more. Also, we have the tools, these tools that are supporting you to make calibration of our devices. You can calibrate the device in the measuring point, but also you can do that in the lab with a software that is called Memosense Plus, or also with a portable transmitter that is this small here, that is new, that we're launching it now, that is supporting you also to measure and to calibrate your sensors. Additionally, we have our buffers and standard solutions, and also some devices that are supporting you to commission and also to make maintenance of your measuring point. Going to the non-hygienic applications that are the utilities in general, we have pH and ORP, conductivity, dissolved oxygen, turbidity, disinfection. This disinfection could be free chlorine, chlorine dioxide, also coming soon ozone. Ion selective to measure ammonia nitrates, sludge measurement, so the sludge level, and the assemblies that are made for open basins and open channels. As you see, we have this Memosense platform, because all these sensors, the same as the hygienic portfolio, you can connect them to the transmitter, the same liquid line transmitter. Also in this case, we have the samplers. The samplers are simply taking samples. For example, in the wastewater treatment plant, we take the samples for those parameters that we don't measure online, like for example, pathogens or coliforms or whatever is needed in the wastewater. And also we have them as monitoring stations, because as it has the same liquid line inside, you can connect any of these sensors to the sampler and to have like a monitoring station that will take samples even in an event. I named the Memosense protocol and the liquid line platform. What is Memosense? Memosense is a technology that was developed by Endress Hauser more or less 15 years ago. Was the digitalization of the analog measurements. It started some time ago because the pH was a measurement that was sometimes problematic to have a precise and stable measurement, and also that the calibration is really lasting and is giving and helping us to have a precise value. The pH measurement is made in millivolts, and when I have no current flowing, I have 0 millivolts, and then I have 7 of pH. So in the old times, if we didn't have a good connection between the transmitter and the sensor, but this could happen because of corrosion between the cable and the sensor, or because the cable was broken or cutted or whatever, I would have 7 as a measurement in my transmitter, but in reality, I would not measure anything. So we developed this technology that what it's doing is on the sensor side, we're measuring still with the millivolts signal, and then we are transforming this analog measurement into digital measurement. With this coil, we are inducting a current that is transmitting the data from the sensor to the cable without any metal contact. It's via induction. Then already in the cable is traveling to the transmitter in the digital way. And on the other side, we have in the cable a small coil that is inducting an energy, so a current that is feeding this sensor so the sensor can work. What is this? Why is Memosense such an advantage? Because this cable could be 100 meters cable, and I don't have any problem in the transmission of my information, because in a way it's digital, so I don't mind if it's 20 meters or 100 meters. Also, the Memosense sensor has a chip and is saving all the information of this sensor, so I can calibrate this sensor anywhere in the process or in the lab. The information will be saved in the sensor, and whenever I plug it to any transmitter, I will access to the information of this sensor. I don't need anymore to calibrate the sensor in the measuring points, because this calibration is completely independent of the whole loop. So the calibration is just important for the sensor, but not for the rest of the loop. And additionally, as it does not have any metal contact, I don't have any more problems with corrosion. For example, in the utilities is important because the environment is really humid, so normally we have problems. And we changed much less cables in the lifetime of the measuring loop. So it's amazing again, Michael, that I have the same problem as today in the morning. So Michael will take the lead of the presentation while I finish introducing you this slide. How is a measuring loop? So a measuring loop, we have, for example, in the case of the pH, we have this pH sensor connected to a cable and a transmitter, and we have this pH sensor installed, for example, in utilities. So it's measuring pH in water. This same pH sensor can be, now we go here. This same pH sensor can be used in the lab. So I can use it in the lab, not only to calibrate the sensor that is being used in the utilities to make pH, but also, for example, if you need to make, because of an internal procedure, you need to take a sample of this water once a day and make an analysis in the lab. So then the same pH sensor that you're using in the process, you can use it in the lab to analyze this sample. In the lab, you can use a computer or this compact transmitter that is called CML18. Additionally to that, we have the buffers, solutions, and also these maintenance devices that would support you to get to your local service of E&H that is in each of our countries. So all together, we go with you in the whole life cycle of the measuring point. So from the measuring point to the sample and also to the lab and the calibration. The idea is that you use the same sensor everywhere, in the pipe or in the open basin, in the lab, and to compare also measurements when you want to be sure that the measuring point it has the right value and you take a sample to compare. We offer you the same sensor everywhere. So you already can get rid of the typical error that gives measuring with two different sensors. Now, Michael will continue with the different parameters and with the application examples.
Perfect. Hey, Flor, thank you very much. This is for the very nice introduction and explaining everything around Memosense. Now it's my honor to talk about the different parameters, what we measure. And I would like to start with the pH measurement. What you see here on the upper right that are the typical glass sensors which are used. That means this is here in pH as well as this, we had for each dedicated application, we have specific sensors to provide. So that means it could be made out of glass as shown here. But very often we see in food and bev processes that glass is not allowed in the process. So that means we have as well as a version, our ISFET sensor which measures the pH as well as with a glass-free design. So beside that we have enamel sensors. And you see here that is the Ceramax CPS 341D. And the yellow part, that is the pH sensitive part. So that means that it is really usable also with the huge surfaces for very sticky medium. And the other part is if you have very rough conditions, even it makes sense to calibrate or to clean the sensor, but you don't want to shut off your process. And then we have this fully automated system, that is the CDC90. And here we can connect a sensor with an assembly. And during the running process, automatically the sensor will be taken out. It can be cleaned, it can be calibrated, sterilized if needed, and then it goes back into the process. So, and of course, needless to mention is that all these sensors are made of materials which are compliant to the food and bev industry, and they all fulfill the requirement for an hygienic design like 3A or EHEDG. So typical applications, what we see that is the quality monitoring of a product, and that can be used for mayonnaise, ketchup, mustard, starch, marmalade, tomato sauce, edible oil. So a lot of things, this is where the pH value has an impact on the quality. Then we use it as well in fermentation processes where we control maybe the fermentation of yogurts and other dairy products. Then we use it for the quality control during receiving, and Maria Florencia already mentioned that the receiving of the milk, that means you directly see whether the milk is good or whether there was an infection at the cows. Furthermore is the quality for the release of products, and that is used during the bottling of beer, soft drinks, or even mineral water. And then the last part is that we use pH also for process optimization. And as an example mentioned here is the carbonation of the sugar process. If we look at the next slide, we see here, that is the pH measurement in mayonnaise or ketchup. And here the pH value is very important for the shelf life, but as well as for the food safety and even more for the taste. Yeah, that means even every ketchup has its own pH set point. The challenge is here that we have a high viscosity of the product. And with mayonnaise, we have a high fat content, which usually tends to blocking. Or in ketchup we have a very high content of sugar. Yeah, and to realize that we have now two different sensors available. That is the ISFET sensor, because here very often glass is forbidden. And the other part is when it is high viscous, as mentioned, we have here the Ceramax, the enamel sensor with the huge surface, which is pH active. And by using these sensors, we were reported by customers that they now could replace and eliminate the sampling, which was happening every hour, to really have a quality control, and now they can do it even inline. So next example is shown here on that slide, and that is the production of bacterial starter. And these starters are as well produced in a fermenter. And beside temperature, pH is here the most important parameter. And you see it already with the installation that is so important that they even have a redundant measurement in case if one of the measuring loops would fail. Why is it so important? That is what you can see here. The blue curve shows you that is the concentration of acetaldehyde, and that is the most important component which is responsible for the flavor of a yogurt. And the concentration of this acetaldehyde is directly proportional to the pH value. Yeah? And that means you try to keep the pH value really in a very low limit. And here at this customer, the most important thing was the continuous quality measurement, what they could do. Here as well as this, they wanted to have a glass-free sensor, and due to the fact that they had a very wet environment, they wanted to have the Memosense technology. And very important for them was that they could calibrate the sensors with the Memobase Plus directly in the laboratory and then bring the sensors to the process where they measured. And besides the calibration, they already got a documentation that everything was done, which they could store and directly present during audits. And the last example now coming for pH, that is the carbonation in a sugar process. Yeah, and here what is done that means the pH measurement is done is to measure the neutralization of the different acids. And beside that in sugar processes they need to remove some organic loads and as well as some inorganic compounds. And the neutralization is done by lime and as well as of CO2 to create the carbonates. And the pH value is now important, to remove all this stuff, and to avoid the foaming of inert sugar, yeah, because fructose and glucose couldn't be used at that part. Here again, the challenge is very sticky, highly viscose medium, yeah, and they really wanted to have a real-time measurement. And what we did here we used now a fully automated system to do the cleaning. And on the left side you see a picture of the inside of the vessel. And what you see with sugar we get the caramel and all the molasses sticking to the wall. But here, that is where the retractable assembly allows the cleaning and the rinsing of the process. That means we still can measure, and by using this automated solution where cleaning was needed we have now a real-time measurement directly in line. So then coming to the next parameter, and here this is a conductivity measurement. And again, this is really the different hygienic versions. Yeah, that means this is all made of certified materials. And as well as we will fulfill all the requirement for hygienic design, like as mentioned earlier, 3H, EH, EDG. So why do we have several different products here as well? And that depends really again that they are specific to each application, what is needed. That means here the contacting sensors like the Condumax TLS16. Yeah, then we have the inductive and the toroidal ones are shown here as a single sensor, and then we even have them as compact instruments. And beside that we have the 4-pole sensors. And the main difference between these sensors is resulted in the measuring range. That means for low conductivity measurement, we would use a 2-electrode system here, the contacting one. But mostly in food, you find the inductive one, because here you can also cover very high concentrations. Yeah, and sometimes, especially in small pipes, we very often use a 4-pole conductivity. This is where you can cover a broad ranges for the different applications. And here, typical applications, I think by far the most important ones, that is the cleaning in place and the stations for that. We talk here about the phase separation, the concentration measurement of salts, and it is used, this is for the quality control and sometimes even for the product recognition. If we use as an example now the CIP, the cleaning in place plant, that is a typical layout, and we see here the different vessels where the cleaning solutions are prepared. And here that means we do the concentration monitoring of the cleaning solutions to get the proper concentration. So that means that these cleaning agents go now to the plant, now they clean it, and then they come back in a return line. And here we install the next conductivity sensor, and that is now used for the phase separation. And the concentration monitoring of course of the cleaning solutions. Yeah? And the good part, as Maria Florencia explained earlier, all these sensors can be connected to only one liquid lysis and then integrated into the PLC. We see here a couple of pictures. The first one is a concentration measurement directly in the tanks. You see the different type of sensors installed directly at the bottom of the tank. And here the concentration is measured. Very important is that you have a very high accuracy, because by that you can save a lot of medium which is used in CIP. So, and the second thing is to ensure that you really have the correct concentration. What is needed is to clean your pipes. Yeah, that means this is the accurate concentration measurement. This really ensures now that you have a safe product, that the cleaning was successful, that no contaminations are left. So then we look as well as this on the return lines, and that is here. That means the phase separation. And now is this by the measurement here of the instruments, or here we see what is returned, what is the concentration of the different cleaning agents, and then it can be decided whether they go back into the vessel to be cleaned again and to adjust its concentration, or whether they can go to waste. Yeah? And by using that, this is with a fast response time, which is in this measuring point more important than the accuracy, but the fast response time reduces then the losses and the energy consumption. So then we come to the next parameter, and that is the dissolved oxygen. And here you see we offer two different sensors. They look very similar. That means the dimensions are exactly the same, but the difference is here the working principle. We have on the left side the COS22D, and that is an instrument which is based on an amperometric measuring technology. Yeah, that means the medium goes into that, oxygen passes, and then it is transformed, and measuring out of the voltage we can then detect or measure the concentration of oxygen. On the right side that is an optical instrument. It is based on the fluorescence quenching technology. And that means we have here an LED that emits light. It goes to a membrane where it is in contact with medium, and then light is emitted and going back, and that is measured again in the sensor. And the concentration, that means and the amplitude, and as well as the time, that is then directly proportional to the oxygen concentration. So that means that is an amperometric sensor, optical sensor. And typical applications for oxygen are, of course, fermentation processes where oxygen is added. Then we have the yeast propagation, where the yeast grows and oxygen is needed for that. And then we have measurements. This is where you measure that no oxygen is present. And that is usually done in inertization processes, close to fillers, where you measure the absence of oxygens to avoid oxidation in the product. And an example here is even in juice, which get oxidized very fast, there are some degassing steps. We come here as well as to the first example, and that is the oxygen measurement. This is when the yeast is made. And what we see here is that the yeast is fed with molasses, and we have some other nutrients. And then the rest that means we create and more yeast is produced. And that the yeast has enough oxygen with this digested that means there is a steady inlet of the oxygen. So this is directly measured, how much oxygen is added, what is the concentration and by this inline measurement we could help our customer to reduce the energy consumption, in this case by 5%, just by measuring the oxygen concentration which is added. The second example here, that is a degassing of the juices. And as mentioned earlier, we have some oxidation products. That means the oxygen reacts here with the vitamins, other ingredients which are in the different juices and other soft drinks. And of course, since that has a change on it, it has an impact on the quality, taste, and the shelf life of the juice. And to avoid that these oxidations happens there is a degassing, and that means we measure then the oxygen before the vessel, and after the vessel is where the degassing happens. And by that, we could provide a continuous quality assurance by the inline measurement that no oxygen goes to the filling process and contaminates the product. So then the next parameters are then our process photometers, which were mentioned from Maria Florencia before as well. All of these instruments are based on the same principle. That means we emit light, it passes the medium, and on the other side we register how much light is coming to the detector. Out of that, we can calculate the different parts depending which kind of measurement is needed. We have here on the upper left side is an OUS AF11, which measures absorbance, and that is very often used to detect milk in CIP solutions, to do phase separations, and as well as to reduce product losses. We have then for fermentation the OUS BT66 to measure here the cell growth or the biomass during fermentation processes. So if we continue that way, we see here the turbidity instrument, our OUS TF10, and that is used for filtration monitoring, turbidity directly, quality measurement in beverages, and as well as to control separators or centrifuge. And to finish that, we also have a color sensor, which is our OUS AF22, and that is used, for quality control, decolorization control, or even for distillation monitoring. The most important thing here is here they can be directly installed in the pipeline, and these sensors can also be installed either in a pipeline or directly into a vessel. So we have here some examples, and the first one is a phase separation between milk and water. And we discussed it earlier about the conductivity measurement. This would work here as well, but it is not extremely sensitive to distinguish between water and milk. In that case, an optical sensor is more preferred because with water you really have a zero line. And when you add even traces of milk, you directly get an increase of the turbidity, and you can measure that directly by the absorbance and get a very precise measurement, especially in the low end. Yeah? And that means it can support now the phase separation and to help to detect now the milk products is in the line. And that is typically used in combination with the conductivity, which measures the acid and the base. And by use of an optical sensor, we have now an early detection really of product losses. We can reduce the cost for the wastewater treatment because the load is not very high. And we even have seen customers who use then the rinsing water to recover even milk products from the pushes when they had the different cleanings. So if we look now at the CIP, this is what we had earlier with the conductivity. We have again, this is the concentration measurements, this is in the vessel. And then besides the conductivity in the SIP return flow, we also install here is the OUS AF11. And they detect now when the first products are coming into the line, and to avoid that they go to drain, they can be recovered. And to go back to the different vessels. The good part here is as well as all these sensors, the 4 conductivity and the 2 optical ones, can be connected to only one transmitter, our CM44P and then integrated into the PLC. Coming now to a next example that is for the color and for turbidity measurement, and that is used in the edible oil process. And in edible oil, we very often have bleaching processes, and we also do some refining steps. This is to remove contaminants and other colors. Yeah, and that means other ingredients could be like chlorophyll and so on, which needs to be bleached. So that means we have here a turbidity sensor, the OUS TF10, the color sensor. 2 of them can be connected to one of our liquid transmitters. And by installing that, we get now an improved control of taste and color. And even more important for the customers here was the fast detection of changes over time. That means this is when they have different batches that they really have a continuous quality control even when they have changing raw materials. Another example is the color measurement of beer, and that is shown here. Luckily, there are a lot of different beers available. That means starting from very light ones to very dark ones. And of course, here, color is a very important quality parameter. Yeah. And the sensor is shown, as shown up here, can be easily installed. That means the color can be measured, and we can even directly translate it into the easy EBC color scale or whatever is needed. The most important thing, connect the sensor to a liquid line and you get a continuous color control, and you can directly and fast detect changes, and you would then take actions to control that. Perfect. So now, as a last part, I show you a couple of combinations, and that is done with the bottling and filling. And at the filler, that is the last gatekeeper. Yeah, that means for the quality control. And that means this is here, you see the conductivity sensor, then we have the pH, oxygen, and color. And they all can be connected to one liquid line. And the purpose is conductivity. That means you can see directly that there are no contaminations. That means any leftover from CIP agents. Then the pH, we had that already, is to assure the quality and the shelf life. DO measurement, important, is to measure the absence of oxygen. And then we have the color measurement. This is to identify this and recognize the product which is in the pipe right now for the filling. So, and then there is one more example of the measurement combination and that is the color and Coriolis measurement. This is here, we measure the ICUMSA value. And that was a typical part which was used. This is for the syrup measurement. That means we have a concentrate, we add syrup, a couple of other things, then we add water, there is a mixing, and then it goes directly on a filter and then to the filling. Yeah. And of course, you have now varying raw materials, and that means you need a very flexible dosing at that part. Yeah, and by installing now the color sensor to measure the absorbance, we have the optical path lengths, and with the Coriolis we get the density and the Briggs value, and out of that we can calculate the ICUMSA value, and that ensures now the quality. We have an improved control of taste and appearance. And of course, this is a very early detection of color changes that you can then flexible adjust the water adding and so on. So, and with that, you already see my nice colleague Maria Florencia. That means I will hand over directly again to you. And I will be available later on as well as this in case we have any questions.
Oh, hi all again. Now with the last part of utilities. Utilities in the food industry is really important. Not only the wastewater, but also what's the water that we are using for the process. In many cases, this water leads to a better quality or a better taste, or the precise taste that you need, for example, in the production of beer or also in the production of coffee, for example. Now, going to these three types of utilities, we are speaking about steam, because sometimes you have steam production or boiler feed water where you need monitoring parameters there. Also, you have the process water, and in the very last part, the wastewater. So talking about the process water monitoring, we have parameters like disinfection, conductivity, turbidity. Also, sometimes we control silica or hardness or iron, depending on the quality of the water that we receive. We can control them with the different sensors separated, or we can also have them all together already installed in a compact panel, which is the advantage of having this compact panel, that we just have an inlet and outlet, and then in the middle we make everything for you. So we have all the installation already made and prepared for all the sensors to work properly. You have an easy access to make the maintenance of the sensors. And the only thing you have to do is to connect the inlet and the outlet. Here, for example, you have for the beer industry, one of the examples of monitoring of processed water, where they are measuring disinfection, pH, conductivity, and turbidity. You see this customer especially requested stainless steel piping, and if you see here, the turbidity sensor is already connected with the position that it needs, and this is the way we present the panels. Then going to the steam, normally the steam monitoring or also boiler feed water requires pH, dissolved oxygen, conductivity, and sometimes silica analysis. Then we have what we call the SWAS, the steam water analysis systems, where depending on the parameters that you want to measure, we have different types of panels that you can mix and match depending on the parameters you need. But also, for example, boiler feed water, we have what we call the compact SWAS. So these compact systems that you have everything inside this box. So conductivity, oxygen, pH, all together inside this box. So which is the benefit? The size is really reduced. So you don't need to have each sensor in different places. You have everything compact, and also for the maintenance, it's easier. Here, in the lower parts, you have an example of a real huge monitoring of a steam cycle. And here is a typical example of a boiler feed water. Last but not least, the wastewater. For the wastewater, normally in the different steps of the wastewater treatment plant, you measure different types of parameters. And you can also have them in a panel. What is important always in the wastewater treatment plant is that this monitoring of, constant monitoring of the wastewater treatment plant is always reducing costs. From one side, because you control what is coming inside, you control perhaps sending something to a buffer tank so you don't overload the wastewater treatment plant. You are sure that in the outlet you will be meeting the requirements of the law. And also you will reduce always the consumption of energy for the blowers, for example, or consumption of reagents in the moment you are making flocculation to reduce some of the parameters. So if you see in a normal or standard wastewater treatment plant, in every step you have different things to monitor. Inlet and outlet are always the most important part. The inlet to know what is coming and to be prepared for that. In the outlet because of legal requirements, and then in between to assure the performance and the good working, the good function of our wastewater treatment plant. What we have is all the parameters that you need to monitor a wastewater treatment plant from the beginning to the end. We have them and we can support you there, from pH to organic load, TOC. It's typical in the food industry in this first part to measure TOC. When you have, for example, a duff and you remove the fat, normally you measure here TOC, then in the outlet you measure COD. In the dairy industry, in the inlet, normally we have an instrument that is correlating to the organic load, so then we can have a fast reaction. So now coming to the conclusion and closing this online seminar. Industry compliance and product safety. How can we support you there? With all our portfolio, we have dedicated instrumentation for the food industry with the correspondent certificates and hygienic designs also. We support increasing efficiency and reducing costs. With the Memosense technology, what we do is to reduce, for example, stock, because you don't need to have one transmitter for each sensor. You don't need to have one cable for each sensor. We did this platform to reduce the stock, to reduce the place, but also to assure a better precision in your measurement, being all the values digital, to have more plant availability, so less time making maintenance, and faster processes. Improved quality monitoring. Here, as we said, you don't need one sensor type per application. You can use the same sensor in the lab and in the process. You can have also the same sensor in the utilities and for water. So you don't need to waste time making validation between sensors, and also you have a precise value even in the comparisons. Optimize also your utilities. As we said some minutes before, you can have all the parameters that are needed to control and monitor your utilities, and that will help the product safety in the process water, also the product quality in the process water, and in the waste, we will support you to reach the values that are required by law. The very last comment is that it's not only our perception that we have the whole portfolio to support you, but also Frost & Sullivan, they are an independent company and you cannot apply for this award. What they do is they make a research of different suppliers and they select every year the best supplier in different topics. And this year we were rewarded for the second time as the Global Liquid Analyzer Company of the Year. And that means that we are a good partner for you to support your processes with liquid analysis. So with this, Michael and Matthias, we are closing for today.
I think we are not allowed to close, but first of all, we can have some questions or answer them directly.
Right.
And I think the first question, Flor, goes directly to you, and that is how or what is measured with disinfection sensors?
Well, we have different parameters depending on the disinfectant that you're using. We could measure free chlorine, we can measure chlorine dioxide, in the near future ozone also. So what we measure is the concentration of disinfectant in order to be sure that you have enough concentration to get rid of these microorganisms that you don't want there.
Perfect. Hey, thank you very much for that. So, and then I see one thing and that was concerning the measurement in tomato paste, and the question was what is the recommended pH sensor, whether that is the ISFAT one. I can say yes, we have seen a lot of customers who are using that in tomato paste. It depends on how many different products you have and how many CIP processes are run. A typical ISFAT sensor is what we have seen from the experience between 20 and 50 CIP cycles. If you have a lot of different products and you do a lot of pushes and CIP pushes every day, then it could be helpful to choose then the enamel CPS 341D. But in general, if you just do the CIP cleaning from time to time, CPS 77D is the correct sensor for that.
Yeah, I have to say now, thank you very much for Maria Florencia and Michael. You gave me an easy hour because I had not a lot of things to do. The technique worked fine. The questions are answered. So I am happy about this seminar and I hope our customers as well. But anyhow, in case you need to know anything else or you like to get more information, so just follow us on our homepage on www.endress.com. This was one of the seminars on a series of seminars where we talk about instrumentation. So this is the first one where we have been talking about analytical. The next one will be about flow instrument in the food and beverage industry. And I already put the link to the presentation for this seminar. So this will be on Thursday this week. And then we have another seminar next week on Tuesday about temperature in the food industry, and the week after on Tuesday about level and pressure in the food industry. And it's a little bit to compensate the situation that we cannot invite you to our location to show you everything and to show you the productions. So therefore, we like to go with these online seminars and present our news for your industry. What I also mentioned, that you can download the recorded sessions. So also the sessions we did in the last year or at the beginning of the year, you can download and watch these sessions. We had some sessions for the food industry as well, and you can download then the other ones as well. That's it from my side at the end. Of course, you can also connect to your local organization in case of any further questions, or just connect to ourselves. And then I have to say, for the ones early in the morning, have a good working day. For the ones in the evening, have a good night. And for the others, have a good free time after work. This is for us now, so we call it a day now. We have been happy that you have been with us. Many thanks for your interest. We hope you could bring something new, and just enjoy the rest of your time. Bye-bye.
Hey, thank you. Bye-bye.
Bye.